I'm not missing chemistry to go to the meeting. Hey. That's good. Too bad you don't know. Did you like it, Tiger? Yes. Kenny and I played a prank on Riley. Played a prank on Riley. What y'all say then? You can't tell her that. So we put a Craigslist ad with all of her, Tiger dog, with all her information on it, and like all the and we click like
This is not hard, but you're going to have to be on your toes. Does everybody understand? Because if you don't listen to me when I teach it, it can be pretty confusing.
What did you say the title is?
Sweetheart, would you just reach up there and turn that off?
How do you turn it off? I'm trying to look.
Far left button on the top. Way up on the top. Top.
Good job. These are chapter 14, section 3. Or section 4.
Yeah, chapter 14, section 3, and then I'm going to come along and put your topic. Yes. I got to take this thing off to write. Writing aggravates my thumb. Chapter 14, section 3. Bronsted, Lowry. Conjugate. Acid-base pairs. That word conjugate, I don't exactly have a definition for that, but I'm going to tell you that it is, you know, an acid loses a hydrogen, a proton, yes, in the Bronsted-Lowry model. Okay? Conjugate means what it becomes after it loses the hydrogen. All right? What's left? Okay. The Bronsted-Lowry acid gives up a proton. The Bronsted-Lowry acid gives up a proton. What is a proton in this case? H plus. You must get that in your brain. The remaining ion or molecule can re-accept no yawning on my video. I did that yesterday. All day long I had to hear me, or really it was sighing. You know, type stuff. And I'm like, oh my gosh. All this stuff comes through on the video. Can re-accept that proton and act as a base Thank you. Double check to make sure. I think I got them all. And act as a base, period. Such a base is known. Such a base is known as a conjugate base. Definition, conjugate base. The species that remains after a Bronsted Lowry acid has given up a proton. Example. We've got HF aqueous plus H2O liquid. What's the difference between aqueous and L liquid? Aqueous is a substance that's been dissolved in water. H2O is a pure substance that is in the liquid phase at room temperature. Okay? Alright, double arrow. F minus plus H3O plus. Okay, so let's look at this. Just by looking, now, can you see on the left side that both substances have an H? Does everybody see that? Yeah. So you must look to the right side of the arrows to see which one actually lost the H. So, who lost the H? HF. So we label this one the acid. Okay? Now then, the conjugate base is what's left after the H is gone. So look to the right side. Who is the conjugate base on the right side? F. So we're going to call it CB. Is that all right? And if you want to, go ahead and write conjugate until you're familiar with that term. Okay? Now then, I like to draw little brackets to hook them together. So this is known as a conjugate acid-base pair. Write that up here. Conjugate acid base pair. Okay? So that's not hard. No. All right. In this reaction, the water molecule is a Bronsted Lowry base. It accepts a proton Why do I keep putting H plus after that word proton? So it will sink in your head. That's exactly right. From HF to form H3O plus, which is an acid. The hydronium ion. Who's the hydronium ion? Good. Is the conjugate acid of water. Definition: conjugate acid. The species that forms when a Bronsted Lowry base gains a proton. Okay, going back to our same reaction. So we've got HF aqueous. That's a Q and not a G. This is our example again. Plus H2O. F minus. And H3O plus. Okay. That's gross. I can't speak. Okay. This one was already identified as the acid. Automatically, that makes what's left as the what? Base. So everybody write the word base here, please. It is extremely easy to identify the acid, okay? And by default, the one on the left side automatically becomes the base. Now then, who gained the proton? Right here. So you hook up your base to its, I'm going to call it the Ca. And what does Ca mean? Conjugate acid. Okay. Now, if you look at the first worksheet, it's conjugate acid-base pairs. Basically, it's working only from the acid. Does everybody? Well, NH3 is a base. All of the rest of them are pretty much acid, yes? Okay. And then on the next page, you see the reactions. Now then, I'm not quite done. So, back to the original equation, HF, and I'm going to leave off, well, I won't, aqueous plus H2O, liquid, double arrow, and F minus. Okay, now we're going to put the two together. When we did the conjugate acid, it was separate. When we did the conjugate base, we showed them separate. Now we're going to put the two together. Who is the acid on the left? So I want you to label. And who is its conjugate base on the right? F minus, Cb. And hook it up with your bracket. Now, by default, this one is automatically the what? And hook it up to its conjugate acid, the one that gained the proton. There you go. Okay? And the brackets are showing you the conjugate acid-base pairs. Yes?
Yes.
All right. Okay, I'm not going to use subscripts. I just like labeling CB and CA. Strength. One little short blurb here on strength of conjugate acid-base pairs. Okay, number 1. Strong acids. Do you have a list in your notes of strong acids?
Yes.
Okay. Strong acids produce weak conjugate bases. Nitric, sulfuric, perchloric, hydrochloric, hydrobromic, hydroiodic. Strong acids. Where did I teach you to look? Periodic table. Nitric, diagonal. Sulfuric, to the right. Stay on chlorine twice. Perchloric, hydrochloric, down the row. Hydrobromic, hydroiodic, or down the column. Okay. Number 2, strong bases. Produce what? Weak conjugate acids. Strong acids and bases ionize completely and have little attraction for H plus. Yes. To retain a proton. So once they ionize, there's really no attraction there for them to want anything back, so to speak. All right, that's the end of the notes. All right.
Happy birthday, Toby. Thank you.
Happy birthday. You're a liar. It's not your birthday.
Happy birthday.
Thank you. How old are you?
Let's sing happy birthday.
It's not your birthday.
29. He's 29.
Liar.
29. King turned 29 today. 49.
Y'all have to excuse my first period. They can get kind of weird.
Trisha loves wands.
Oh my goodness, poor Trisha. Y'all quit picking on
You should
Trisha.
see our choir calendar. On our choir calendar on April 19th, it says Trisha and Juan's
Trisha, you like
name.
insects?
April 19th?
Yes.
Oh my goodness, that's a week away.
Insects.
You're gonna have your first date? Huh? That's a week on your birthday. Hey, your birthday?
That's so great. Dude, everybody's excited about Trisha's birthday.
I've been telling Juan that he blew it. When he didn't speak to you that day, when you went up, what was it? He didn't speak to you that day. He did that for you.
He started laughing when I thought of it. When you thought that's where you're going. But if she hadn't been to you, would have laughed so
All right, this is the paper I want you to get first, please. Now then, this is going to require you just to do a little thinking. Again, you're filling in like pieces of a puzzle. They give you parts. So it's basically subtracting an H or adding an H. Does that make sense? All right, this is your acid. This is your conjugate base. Okay? Now then, yeah, all of these are functioning as acids. I forgot that there was listed columns. All right, so let's look at our example up here. H2SO4. How many H's present here?
2.
How many H's present here?
1.
Now, this is a neutral compound. When you lose something off of it, it is no longer neutral. It will be charged because hydrogen is a positive 1. So, it's no longer neutral and it will be negative by 1. Does that make sense? Okay, on the side where it says the equation, you start off with this acid on the left, and you're simply going to show the H plus the conjugate base. Okay, and this is not a complete reaction. Does everybody understand that? It doesn't look like your examples on the notes, does it? It's just talking about the removal of the proton. Everybody with me? Okay. Here's your acid. How many H's are you going to take off? 1. Just 1. These, and we're going to learn this later, they go through a process, but they only remove 1 at a time. Okay? All right, so that leaves us with how many over here? 2. Yes, my bad. I don't know why I wrote it. That's a P. PO4 now. Negative. Okay. So the acid goes on the left of the double arrow. What goes on this side? What did it lose? H plus plus H2 PO4 minus. Yes? All right. Now, here is your conjugate base. So what do you have to put back on it?
H.
And when you do, it makes a neutral what? Compound.
That's what I said.
These are ions. These are compounds. Neutral. Unless you get down here. Okay? Alright. So what starts on the left?
HF.
Okay. Double arrow. And you get a what? H plus plus. Alright.
So we said she's confused.
I didn't say that. Tiger said that. Oh, I'm like way ahead of you. I got to number 5.
Okay. Okay. Everybody look. Look at number 2 and number 5. Can you make the connections? Okay. I told you that they lose their H in a process, in steps. Not all 3 at once. Does that make sense? Okay. So now, what's going to be left? HPO4. Now, what's the new charge? No. What's the new negative charge over here? You lost another positive H. Negative 2. See, this one was negative 1, wasn't it? Now you lost another one, and it makes this one. Oh my goodness. What is,
That is crazy.
look right here. What are we heading to? No. Can you recognize PO4 negative 3? What is that?
Try.
A polyatomic ion. Who said that? Thank you. All right. But we're not there yet, are we?
No.
Ah, look down there at number 8. Do you ever get there? Yes. So when you remove this H, it becomes what?
PO4 negative 3.
Thank you. All right, I'm going to let y'all.
No.
Oh.
Don't do that. Yeah, let's
How'd you
How
die?
about we just
Finish the whole paper.
And let's finish.
Now remember, this column has one less H than this column. Okay, go to the next paper. I have you a nice example here. I think you can do this one very easily. Okay? I have a worked example at the top. Do you think you need me to do one with you?
Let's do
Yeah.
this in case.
Yes.
Okay. Now then, what I tell you is critical in your analysis. You have to look at both things right here. You have 4 H's here. You have 1 H here. Please go to the other side. Which one lost an H? NH4. So automatically you label this one the what? Acid. Now if you look at my example, you must see that your acid is not always going to be the first one in line in the reaction, is it?
No, ma'am.
Okay. All right. So, what is left? What is left of your NH4? Who am I drawing to? Okay. So that makes this your CB. Everybody agree?
Yes.
Okay. Automatically by default, this is labeled your what? Draw your little bracket to whomever is left, and automatically by default, it is the CA, conjugate acid. Yes?
Yes, ma'am.
On the example, why would it NH3 be considered the acid?
Because it did not lose an H, sweetheart. Again, it's following the H. You have to examine which one lost the H. Does that make sense?
Yes, sweetheart.
Because in the Bronsted-Lowry acid-base pairs, one is losing and somebody else is gaining. Okay? All right, I'm done. Y'all are on your own. Now, I want you to think. Learn to be